in the previous slide, I asked you about this earthquake swarm that was happening here on this island in the Canary Islands, and wanted to know where you thought the eruption was going to occur and whether it was going to happen soon. Well, we were looking at this time span here, July to August 2011, and there were lots of earthquakes during that time period. But the very next month, there were even more earthquakes in the same spot, lighting up that magma chamber again. What was interesting, though, is that what happened next, later in September and early October, the earthquakes moved, and then they got shallower. And then down here by October 12th, they show that an eruption was already underway and there was magma coming up to the surface. It turns out that that particular spot was underwater, and all this might be sounding familiar, that date, an underwater eruption. Indeed, this earthquake swarm that we were looking at eventually led to an eruption right over here 3 months later, the one that we saw with the harmonic tremor. So what this tells us is that you have to watch earthquakes and see where they are, and most particularly looking at the depth. When earthquakes start getting shallower, that means magma is moving shallower, and it will tell you more information. We were looking at this big magma chamber that was down pretty deep, and we needed to wait until the earthquakes got a little bit shallower before we issued our emergency warning and knew where that magma was going to come up to the surface. Quite a bit away from that magma chamber, so it migrated through a complicated plumbing system to get up there. Well, our next warning sign is related to the gases that are released by magmas. And if you think about this here, if you happen to be a bit of magma down deep, deep underground, you've got the weight of all the rock above you pushing down on you. And what that pushing down does is that if there's any gas that's in the magma, it's being pushed and trapped and confined. But as the magma rises up, there is all of a sudden less weight of rock on top of it. And all of a sudden there's less weight confining the gases. So the gases, when the magma starts moving up into shallow levels, are able to really quickly escape and get up to the surface and sort of give a warning sign that there's magma that's rising up. And so this is one of the reasons why they're constantly monitoring the amount of gases and the types of gases in Vesuvius, because when you get new magma rising up, it's going to be releasing different gases than the magma that's been sitting around for a while and has already released what it had in there. So that's one of the reasons why they're monitoring those things. And you can see that here's the amount of gas emitted by Mount St. Helens, which erupted in 1980, and the amount of gas kept going down and down and down for the years and years and years following the eruption. So there's definitely a relationship between gas emitted and magma. And just an amazing thing. If you look at this rate here, this is tons of gas per day coming out. So way after the eruption ended at Mount St. Helens, there were still many, many tons of gas coming out. So certainly a lot of things to look at there and monitor. Mammoth Mountain, the famous ski resort here not too far from us in Southern California, is indeed a volcano, and we know this because of not only the composition of the volcano and of the mountain and the lava that we see that's cooled and formed layer upon layer to make this mountain, but also more recently there are actually areas of trees that were killed because of the release of volcanic gases from magma that was intruding up from underneath. And of course you can sample these gases directly like we saw in the movie about Mount Vesuvius, or using the spectral signature of gases from a remote system. So you can just sort of point a special instrument at the gas and find out what it's made out of. Certainly more convenient. So this next slide here, you're going to answer this. You're going to go ahead to the next slide and answer a voice thread about this particular question here. What do you notice about the relationship between the amount of gas released, which is up and down here, and these gray bars, which is when Mount Etna erupted? Does monitoring SO2 gas alone always give you a good warning about an eruption? You tell me.